when you're creating document files, you'll give it an extension of docx and so on. So file is basically a named data structure which is of a permanent nature, because when you run your program, it just doesn't vanish like other variables. Till now, you've been doing variables, dictionary, lists. You create a program, you run a program, the variables are created, and of course, when the program finishes, they're all gone because memory is volatile in nature, right? So nothing gets saved. But a file is a data structure that will help you to save contents, whatever they are. You can save variables, you can save dictionaries, you can save lists, whatever it is. Now there are two kind of files that you can, almost every programming language will let you work with two kind of files. One, text files, that means normal data, which can be read by human eye. So you can create a text file and you can also create it by hand because it's just text file, normal characters, and you can create a text file through a program and then you can open it and read it. So it's human readable and human editable, right? On the other hand, binary files are files that cannot be read by human eye. So what is the advantage of binary file? I mean, all that the computer is doing when it is saving is it's saving it in binary. So what do you do with binary files? Why do we even use binary files? Because objects can only be saved in binary files. Now, what are objects, which you're not so much aware of yet, because we haven't even come to the stage where we can talk about object-oriented programming, right? So I'll show you how to work with both kind of files and then write a short program, kind of explain what they are, and then let's see how it goes. If I can give you a small assignment, which you can do, good. If not, there's not much I can ask on a quiz on a file. I mean, there are only maybe 10 things that you need to know about files, but they're very simple to work with. Logically, there is not a lot in it, okay? But you could make it as complex as you like. Again, I'm keeping it simple because my aim is so that you know how do I save something to a file and how do I read something from a file. So it's of a permanent nature, that its main advantage, which none of your variables are. So you run a program, your variables are created, dictionaries are created, lists are created, and they're gone, like the gradebook. Do you have that information anywhere? No. So you run the code, you give the student number and the data again, you can see the printout, and then once done, it's not available. It would be nice if you could keep the student number and the list of marks in a file, like something that you could put on paper and save it, so that if it is required again, all you do is you pick up the data from there and you work on that file. So the program that you've done in your assignment 3, where you've read the student name and the marks and put it in just dictionaries and lists, can be very easily done with files. So files has a big advantage. Next to files in its kind of complexity are databases, right? So instead of saving your work in files, which are restricted in size, I mean, there can be very large files, but when you talk about humongous amount of data, then you save data in databases, right? Which again, you could do in Python. So there is no end. Python is a very versatile language that is being used, especially in the networking world, right? It is being used very widely in the networking world. So if nothing else, you must at least know how to read something that is written in Python, to make changes in Python. And that won't be possible till you know Python. So let's look at how you create files today, right? So I'll show you how to create a file as you do, how to read from a file, how to create a file through a program, and so on, okay? So as always, we'll kind of write a program. We'll put our comments at the head. We now know that multi-line comments can be put with the triple single quotes. So see that you have your name. Not much time is left. We are in week 12 today, and I have one more week to go, 13. So what I'm trying to do next week is whatever I can, I'll bring examples and I'll show you how it works. Because the last week will be your exam week also. Okay, and the exam week will be a mixture. You will have code to write, you may have multiple choice, it will all be a mixture. But instead of asking you a complete program, which somehow I'm not very sure if you can do, maybe I'll ask you snippets, right? So that's how it will go. That's how it's working with you guys. But the last week goes for the final exam. So it will be a mixture of all you've done. So I've given you everything. I've given you writing code. I've given you quizzes. I'll give you a mixture. So, I mean, whatever works for you. So it's July 31st today, last week of July. And the aim today is to work or to learn how to work with files. And both files, as I said, there are text files and there are binary files. Right? So text files are files that human eyes can read and create. They're just normal, like normal files. If you open up a Word document, you know what it says. Whereas a binary file is something that you can't read. It is all encoded and decoded by the system when it reads from a file. So to create a binary file, you will always have to write a program. To read from a binary file, you will always have to write a program. But with text files, you could create a text file wherever. So what I've done is, and I'm going to do it with you also, you can create, if you have text pad, if you have notepad, whatever you have, really doesn't matter. I'm going to create a text file for you. Why am I not using Word? Because remember, Word is full of formats and everything. So try to use a program that has no formatting in it. So I've just opened TextPad and I'm going to put some data into it. Okay. So I'm going to put my name. And so I'm creating a file. I'm giving my information, right? I'm giving the address of my, maybe my office. It's my office location. And then maybe my phone number. So here I've created a file which just has data, simple data, right? Data that you can read by your human eye. This is an example of a text file. So use TextPad or Notepad++ or any other program that you have to create a normal text file. Don't use Word just because Word has its own control characters. Okay? I've created this file and I just save it where I'll keep my program. Now there are a few options. You could save it anywhere, then you must know exactly where I saved it. You'd have to give a path. Or it is saved on here, 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 and so on. What I'm going to do is, since I'm working at a particular place, I know where I'm going to work. I'm going to save it in, because I mean, I organize my work. In Python, I have a so here the Tuesday section. So it's right here. Right, and notice how I keep all my programs in the same folder so that when I need them, I have them. I'll create a directory here just so that all my files can go in here. Anything that I do with files. Files will usually have more than one file associated with it. So you can call it input file or whatever you like. Really doesn't matter what you call it. You can call it personal information. Just remember that name, okay? So I've called my file personal information, and it's a .txt extension because I use TextPad, and it has been saved in a particular directory. Now I'm going to write a program that will show you how to read from that file. So if contents are available in a file, how do you read it? So this could be a file where maybe I had kept the student numbers and their marks in the assignment. If I know how to read the file, all I have to do is pick it up. I have to know. My first is the student number, second is the list of marks. Again, a student number, list of marks. And I have to know the format of my file. Only then can I work with the file. So I'll take this simple example first so that you know how to work with files. And then we'll create a file. We'll keep a student number and the list of marks. Student number, list of marks. Student number, list of marks, and we'll read from there and work with it. It's not a tough job at all. Okay. Okay, so I have this file. And I've called it personal information just so that I can remember. It's just a normal text file, no big deal at all. Now I'm going to write a program that will read from this file. So before you read from the file, one, of course, you should know the name of the file. If you want to read from the file, you have to open the file in the read mode. If you want to write to the file, you have to open the file in the write or the append mode. Write means fresh. If anything is already available in the file, it will be erased and it will start from the beginning. Append means there is already something in the file and you are adding more at the end of the file. So basically 3 modes. Do you want to read from the file? Do you want to write to the file? Do you want to append new data to the file? So you need the file name and the mode in which you want to open it, right? So I'll show you how to read, and then I'll show you how to write to a file. I can write to the same file if I like. I can add more information. I can write the address of my college if I like at the end, right? That I'm teaching in Georgian College and so on. So it's as simple as that. So for the first thing first, how do you read from the file and how do you basically write to a file? So let's read from the file. So what will be your first step before you start reading? You have to open the file, right? It's like any file that you work with. Before you start anything with it, you have to open it. So you use idle to open a PA file, you use Word to open a Word file, but you open the file, okay? Now you can save to save it, you can make changes to it, but that's the mode. Okay, so let's reading contents of a file. The first job is open the file. If I need to open the file, definitely I need to know the name of my file. Otherwise, how will I open the file? And when you open the file, you have to create a file object. A file object is created. So, and it's like a integer or a float number. It's called a file object, F with a capital F. So it's that logical name that you will use throughout your program. So you can give it any name you like. Again, we will give useful names. We will follow the rule of naming them with Java convention. Okay. So I'm going to call my file input file. You could have called it personal information if you like. It really doesn't matter. Okay. So input file is a file object. So you've heard integers, you've heard floats, which is real number. You've heard strings, and now you're looking at a new data type called a file data type. It's called a data object instead of a file because it's not a single value, it's a data structure. You've heard of lists, you've heard of dictionaries. So file object is another object. Now this object is just a little different from a normal data type. We call them data objects instead of data types. And at this point of time, I don't feel that you will understand it just because you're not there, right? Not that you don't know nothing. We haven't studied it. Okay. Okay. So how do I open a file now? The command is open, right? And now the name, notice how as soon as I say open, it's given me a few options. I won't go into all of them, but it says open a file and return a stream. It raises an IO error upon failure. So if I'm unable to open a file, it will give me a IO error. So if I can put it in a try except block, then if there is an error, it will catch it. Otherwise, it will create a problem. So what kind of errors can come? I'm trying to open a file in the read mode and the file does not exist. That's an error, right? Or it could be some operating system error that I don't even have an option. So what I'm going to do is just for the heck of it to show you that the file doesn't exist, I'm just going to call it PA. I mean, I know there is no file called PA. I know. Okay, so where is it going to search for this file? It is going to search for this file in the same directory that I have placed my file in. So in Python, when I went to your programs in Tuesday, remember I created a files? I'm going to create my program right here. And my file is also in the same folder. So if you don't give a path here, this is called a relative path. Your directory, where will it go in? The first thing where it will go and look for that PAR file is in your current directory. And what is your current directory? The directory in which you're working right now is your current directory. Actually, Python has all these commands. You can always find out your current directory. There is a module called OS, and you can say OS print current directory, and it will give you the current directory. So you can always find out where am I right now, and then you can use it. But this is the simplest way of doing it. I have placed my file and the program I'm writing in the same folder. So when I run this program, it will look for PA in that folder. If it can't find it, of course, it will come up with an error. And I'll show you that it will come up with an error. And the second parameter, which is the default, is R for reading. But for your information, R is the default. R for reading is the default mode. It's called the mode in which you're opening your, or whatever you're doing with your file. So there is a read mode, there is a write mode, there is an append mode, right? So do you want to read from the file? Do you want to write something to it? Do you want to add at the end of it? The difference between read and write and append. In case of write, if the file already exists, it's whitewashed. All contents are lost and it starts from the beginning. So old contents are lost. In append, the old contents stay and you're adding at the end of the file. Okay. So now I won't even go further. I'll try to open this file in the read mode and see if I get an error. Because there is no file called PA. Let's see if it gives me an error. Here I have an error. It says, what does it say? File not found. So if I have an error, that means it would be nice to put this in a try except clause, right? So if I can't find a file, I found an error called file not found error, which means there will be other kind of errors too when I'm working with file. You've heard of a few errors, haven't you? You've heard of a value error. You've heard of a name error. You've heard of a division by zero error. So you've heard of those errors when you were working with normal programs. Now I'm showing you another error, which is called file not found error. So what will I do? How do I take care of it? I'll take this, I'll put it in try, and then I'll write an except here. Easiest way. And in the except, what will you do? You will say, what kind of error am I looking for? Now we've found one name, file not found error. There will be more. How do I look them up? Google it and see what are the different kind of errors that are available. So if I say file not found error, that's the error I saw here. It was called file not found error. So at least know there is one of this. And it says no such file or directory. It tells me, right? Here, I know that error. And what will I print? To the user, I'll print something like. And sometimes you can make the system also print its own message. Again, I'm not going too much there detail. I'm just writing my own message. No such file or directory exists. And just to be on the safe side so that other kinds of errors may occur, I'll write an empty except and I'll print something like some IO error, right? Some IO error occurred. So I don't know what kind of IO, but IO means input output. But as you become more efficient and proficient in occurred spelling. Occurred. I think there is one R and not two R's. I could be wrong. I think there are two R's. Anyway, right? So once you become more efficient in writing programs and working with files, you will know, oh, this kind of error can occur, this, and you can write your different except blocks for everything. I'll repeat something, guys. I've noticed it in a couple of assignments. Everything that you need to do, you should do in your try block, because if a problem occurs here, you don't want to do the rest of the things. Though there is another way, you can always add an else at the end of it, which I haven't done, so I'm not expecting you to understand it. What does else say? Else says, if I have no errors, then do this job, right? That's what else says. But a way of the rest of the ways, I put my processing here. So the rest of the processing. So processing file if no errors. I'll put it here. So this way, if a problem occurs, it will stop right away. If there is no problem, then it will process everything. So now let's try to run this code. The pass still doesn't exist. The only difference is now it will say no such file or directory exists and the program will stop normally. So see the difference between the two. That's why we use try excepts. You don't want to show your user those red error messages which a normal user will not understand, right? And if you have, you must have done try and except in your assignment 3, where I said only integers can be input. So if you try to give Anju when it is asking for an integer marks of the students, you'll have a problem. Put it in try except and it will take care of it, right? Okay. So now you know the use of try except, you've done it, right? Okay, so my file is open, but that file is wrong. There is no file called PA. So what was the file called? The file was called personal information. And it was a text file. Now I'm repeating. You can give a full path name here. You can give a full absolute name, C:\, /this, and so on. You can give a complete path name if you like of your directory. and it will go and look for that file exactly there. So you can place your file anywhere, or you can give a relative path name. Relative path name means wherever I am right now, wherever my program is right now, from wherever it is executing, relative to that, where is my file? So you can, I'm not sure how many of you are aware of absolute file names and relative path names, but I really don't have time to kind of go through it. So I'm doing the easiest way. I'm putting the file with which I'm working right in the same directory where my program is. So it doesn't have to go and look anywhere. But you could have said C:\/ twice, // because it has a meaning. I don't know, documents, // courses, // Python. I could have just put it. So I could have taken this whole field, whole path here, which I have in my courses and Tuesday programs and in files. I could have copied this from here and I could have placed it right here. Instead of this, I could have just put it right here. I could have given a whole complete path name, and because / has a special meaning, you could have to do double backslashes, or remember from our regular expressions, you can put an R here. R means take it as it is. So again, you're still looking, oh, the file still is not complete. Last, and what is the file you're looking for? Personal information.txt. Oops, personal information had a blank there. So you can give a full path name if you like. A complete path name can be given. And this is an example of an absolute path name. Absolute, where is it, from where does it begin, and so on. You can also use relative path names. Let's see if we have any problem here and if it runs okay. And it does, right? So using complete path names or using relative path names depends upon what you're going to do. So R is for raw. So because I'm putting it in the same. So if you want to put your note for yourself, you can say, can use absolute or relative path, right? And an example of an absolute path would be this. That's an absolute path. And then the name of the file. Because then you don't, I mean, you don't care where is it in relation to where I stand. So this is an example of an absolute path. And what I am using is a relative path name in relation to where I am right now. And where is my program? In the same directory. So I don't have to say anything. Right? Are you aware of the dot and the double dot directory names? Have you heard of them in your in your other courses? Dot stands for the current directory and double dot stands for the parent directory. You can create a full path name using current and directories of yours. So you can give it in relation to where I am. But again, as I said, I don't want to go into this and I don't want to confuse you. I'm just going to do it normally. So there is my file. I've opened my file in the read mode. Now, after I open my file in the read mode, what would be your next step? To read from the file, because that's what you want to do. Now, there are two ways in which you can read from a file. You can read the entire contents of the file together. We'll say, is that okay? Sure, it just is. I mean, it could depend. If you have thousands of lines of code, you wouldn't like to read it together. But my personal information, there are 3 lines. I can read it together and I can just spit them out, right? So you can read the file. You can read the contents in one go. And using the read method. There are 2. There is a read and there is a read line. As the name suggests, read will read the entire contents as a string. It gives you a string. And read line will read 1 line at a time. And how is line differentiated? When you saved the file, you had put an enter key. So that's what a line is. I'll also show you how to create your own file. So don't worry here. So read the contents of in one go using the read method. And of course, when you read it, you will have to save it somewhere, right? So let's save it in contents. I mean, whatever you want to call it. Or you can save it in personal I've created a personal information variable, which is of type string. When you use the read method, it returns you a string. And what is your file called? Now for future, you will use input file. You will not use the name of the file. Once you've made this connection has been made. What is the connection? Personal information's logical name in my program is input file. It's a stream, right? So now you can read the file and you can just, it's a string that you are reading. You can put it wherever you like. I've put it in a variable called personal information, and I'm saying input file, and with the input file, I'm going to use the read method. Simple. And now, of course, to see that it really read it, what will you do? Print it, right? So let's print. Let's print something like a heading like personal information. You can start with this double and finish with a single or opposite. So please be careful that you do it. Okay. Oops. Wrong place. Of course, you could have centered this also. From your string manipulation, you can use center also. And now, just for the heck of it, I'm going to say print. And I'm going to take this variable called personal information and print it here. And there it is. It will read the entire contents of the file, and you're just spitting it out. So when the files are small, like I just have 3 lines of code, then it's not a big deal, right? But when the files become big, thousands of lines of code, then you just can't do this. It's not. Or if you're interested in reading 1 line at a time, it can be done. Even if it's 1,000 lines, it will just print out the 1,000 lines. But when you want to work with each line separately, then this is not how you will do it, because it just reads it at one go. Then you have a string. And in that string, if you wanted to work with that string, you'll have to break the string yourself on new lines, then pick up the data, then use string manipulation functions, and so on and so forth, right? Let's see if this program works. And don't forget to close the file. So now after you've done the processing and everything, close the file. And the method to close the file is called close, right? And the name of the file was input file, if I'm not mistaken. That's the way you close it, though nope, because it's a method. It's not a function. If you kind of look at it, 3 things: open a file, read from a file, close the file. This is the easiest. Of course, after you read from the file, you will do something to it. It's just not for fashion, you know what I mean? So we'll take a better example, but this at least tells you how you open a file, how you read the contents of a file, and what do you do with it depends on you. I just printed it. But if I wanted to do more with it, we'll take a bigger example. Okay, let's see if this works. So remember the file? The file, I had put my name, my office location, and my phone number in it. All it will do is open it in the read mode. It will read it together and it will spit it by the print statement. Let's see how it works. Here it is. Not so tough at all, right? And the most important thing that you have to keep in your mind is personal information file exists. So if I had 20 or 40 students in my class and I had kept a list of your marks, I don't want to enter those marks every time in a program. I'll keep those marks in a file. If I want to calculate the average, the maximum, the minimum, whatever it is, I can just read the contents. I need to learn how to work with them. And this is all you've learned till date. I'll show you, I can show you how it works. And then you work with the contents of the file. So this is the read method, right? There is another method called read line. Let's see what does that do. So I've opened the file in the read mode, and now I read it using the read method. I'll also show you how you can also read information using the other one. So instead of, I haven't yet closed the file, okay? But you have to remember something. once something is read from a file, so it's reading, the file pointer reaches the end. If I try to read again, there is nothing after that. So what will I have to do? I'll have to open the file again so that the file pointer goes to the beginning of the file. So before closing, now if I've read everything, by this read, I've read everything. If I now try to do a read line, nothing will come out. Why? Because it is read it, it's finished. It's like done, done, done. It's at the end now, end of the file. So there's nothing to read. So again, to make the file pointer go to the beginning of the file, the easiest way is to close it and open it again. It's like closing the book and opening it again. So if you were reading from a book and you've read it and you're at the end of the page, you're done. But if you say, oh, I'll again close my book, though you can just, start from the beginning. But here we'll have to close the book again, open it, and then you can start reading from the beginning. Or there could be a better way of just saying, take the file pointer and put it at the beginning of the file. Again, I'm just doing what's in your book, not going any further, not making it complicated. Okay. So now once I close the file, and if I want to read again, now I want to read not one, I want to read one line at a time. Right? So instead of the read method, I'll use the read lines method. Okay, so what will I do again? I'll again open it. So this one works, right? So I'll again open it. Of course, in the read mode. Right? And now I'll read per line. And the method is, you can use the same variable, really doesn't matter because I've already printed it. And instead of read, it is called read lines. And let me double check if the L is capital or small. Small. There, that's the read lines method. Right? So read lines will read one line at a time. And now since your data can have more than one line, it will put it in a data structure. It will put it in a list and separate each line by a comma. Look at how the output will come. Look at the output now. So it depends on what you want to do. It won't be as neat, but whatever it is, right? Okay, so what did I do? I closed the file. I opened it again. So you'll have to open it again. I read it using the read lines method, and I'm again printing it for you to show you how it occurs. And always remember to close your files. Always remember to close your files. If you don't close your files, I'll tell you what. One, this is something that needs to be done as a operation that, oh, I'm done and I have nothing else to do. Two, when you're writing to a file, if you don't close the file, you're actually writing in the memory buffer when you do a write statement. So if you don't close a file, the contents of the memory buffer are not transferred to the file. Remember, the file is on external storage. So when you do writes are done in memory. So it kind of fills up a buffer in memory. It doesn't say, oh, write every time, write every time. Why? Because it's expensive. Writing to external storage is expensive in terms of time, right? So it keeps writing code in the main memory. And when its buffer is full, it will take the buffer and dump it out on the external storage. So if you don't do a close and your buffer was not yet dumped out or it is not yet full, you will lose those contents that are in the buffer. So it's always a good practice to close files. Okay. No resources should be left open, like a network connection, like your phone. You call somebody, right? After you are done, don't you say stop? You press the stop button to say I'm done. Same thing, right? Otherwise, the call just keeps going on, unless, of course, one of you disconnects. But if not, then the call just goes on. And that's not what you want to do. You're wasting resources. Let's see how the output looks now. Notice the difference now. So this is coming from the first one, normal read. Much neater. It read it, it spit it out. This is not looking as neat. So this is my first line. And it has saved it with the \n. Remember, \n is for new line. This is my second line. And this is my third line. And do you notice the data structure in which it has saved it? In a list. You'll say, oh, the first is easy. It's neat, it's everything. But suppose I had the marks of my student and their names, and I wanted to do something with the marks, average. If I just spit it out, it's okay. Spit is okay for displaying purposes. But if I wanted to do something with the contents of the file, I have to retrieve them. I have to pick up one record at a time and work with it. Otherwise, how will I work with it? Right? So now that I have a list, you know how to work with this now. You can use a for loop. You can extract what's as the first element and do whatever you want to do. So it returns a list. In the first one, it returns a string. And in the second case, it returns a list. Let's see if we can do something with the list. You know how to work with lists. It's just a list now, right? Nothing. It could be names. It could be numbers. But of course, you have to know what it is. Why? Because if there are marks and there are strings, you can do math with it. You'll have to convert it into an integer and do it. Okay? Even if it was an A155, only 155 or something, or just a number and it wasn't here, it would still be a string. Notice how each one of them is a string. So I'll have to convert it into an int or a float or whatever before I use it. So that's a list. So now you know two things. When you use the read method returns a string. So you know, read the contents in one go using the read method. And what does it return? It returns a string. And what does this return? It returns a list. A list. And what is each element of the list? Each element of the list is one line of your file. But it returns a list of strings, right? So if I wanted to do something with it, and see, this is how it will help you now. You've already done list. Now, if you wanted to do something, you can do it. You have it here. Where do you have it? You have it in personal information. Okay, let's try to do something with it. What can you do with a list? You can browse a list. You can do a for statement if you like. So for I in personal information, this is the most common thing you've done. You can print it out one per line. Print I. This will print it one per line. Now, if they were marks, I would pick them up. I would convert them into int or float. I would put it in a sum variable and I'll work with it. I'll show it to you. It's not so difficult at all. So if I give you a list of marks and I say find the average, you'll read it, sum them up, convert them into ints or floats, sum them up, divide by the number, and there you go. Let's see what this does. But they're all strings. Keep in mind, they're all strings. Oops, missing what? Oh, missing, forgot my parenthesis. So the print function is a function. It needs parentheses in its call. See here? Now the thing is, why is it leaving an extra blank between Anju Chawla blank, again this, again a print? Okay, I think I know. One, the \n goes to a new line, and then print automatically goes to a new line. That's what print does. If you don't know, when you say print, 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 automatically a new print starts with the new line. So \n is taking to a new line, and then the print statement is again taking you to a new line. Therefore, you have two blank lines in between. So there are the contents of my file. Now imagine that all you had was a list of marks, right? And it can be anything. Like I'm just doing it very simple. I just have strings. You could have in each element, you could have the name of the student. You could create a dictionary. You could have a name of the student and his or her marks. Name of the student, his or her marks. It will pick up the dictionary. It will pick up, then you will have to pick up the key and the value, and then you can do whatever you like with keys and values. So files are not limited to just string data. You can do whatever you like with your. Yes.
Are you going to mention JSON or anything like that?
No, nothing. No, we are not doing objects or anything in files, right? I'll mention how file, it can be saved using a module called shelf, the binary files, but nothing in JSON or anything. No. right? So these are text files. Okay. So now, just for the heck of it, if I want it, okay, I'll try to do a little more and then come back and do more in reading. So we've learned how to read from files. Simple, right? Now this is a simple file which only has text content, but we'll go further. But before I go further, I also want to show you how do you write to a file, because maybe you are interested in taking the user's marks and putting it in a file, taking the name and putting it in a file. You could do anything. You could say, please input your name, and you save it in a file. You say, please input your marks and put it in a file. So if you know how to read from a file, you should also know how to write to a file. So I can put it in the same code if I like. I mean, it's not a big deal, or the same program also, or I can create a different one, but it's not a big deal as long as you know what to do. Okay, now let's learn how to write to files. Quite obvious. If you know how to read, it's quite obvious you should know how to write to files. So the difference between the two, write, if there are any previous contents, they are lost. Append will add at the end. It will keep the contents and write at the end. And if the file does not exist, it will create a new file. Because it just says, oh, you're trying to write to a file, it does not exist, I'll create a new one. Okay, so write or append to files, it creates a new one by default. And the difference between write and append, write will clear. And what does append do? Append will add at the end. Append has come from adds, end. Add and end become append. Okay. So if there is no file, write and append are the same thing. You're doing it for the first time, right? If the file already exists and you're trying to write to it, it will clean the previous contents. If you're trying to append to it, it will keep the previous content. So if you want, same process, same steps. Open the file, write to the file, close the file. Same three process, same three steps, right? Now I'll show you both. I'll try to add some information using append to the file that I already have, my personal information file. Or if I want to create a new file, I'll just create a new file. I'll add both. I'll show you both. And again, you can read something from the user and save it. You can save some hard data, whatever you like. So I'll try to kind of go a little. You've done all this in the sense that you know how to take input from the user. Okay, so let's open a file and we'll call it whatever you like. I'll call it output file. You know what? Instead of saying output file, I'll call it. No, for now, we'll take a simple example first. I'm afraid to do big examples with you because I want to go slow, right? I have been going slow, but I don't want to do something to overwhelm you. Okay, so let's create an output file. To open a file in the output mode, again, you will have to give the name. Which file do you want to open? Which file do you want to create? You can use absolute addresses again. You can use relative addresses again. Okay, so let's create a file by whatever name you like. It really doesn't matter. Let's create a number file or whatever. Or marks file. Or your names file, really doesn't matter. Names of my students. Or student names. This is the name of this is the name of my file. Oops, can't have blanks or anything in it. It's going to be a text file. It can have. It's going on the operating system. Okay, and now the second one is compulsory. Read is default. Let me open it in the write mode. Here. So a file called student names.txt will get created in the same directory where you are saving this program. Does it already exist? No. So a new file gets created. If it already exists, then it will write to that file. That means it will clean its previous contents. So you'll say if it already exists and I want to clean its previous contents, why would I do that? Then use append. Use A for append. Okay, so we'll do the same thing. Let's do one by one. So it creates a new file. and opens it for writing. Okay, now what do you want to save in the file? Some student names. I could just say write this, write this, write this, but I'm not going to do that because I want to read something from you, okay? Because you've done input so many times, right? So let's take some name of the student. Let's use an input statement. It's not that you can't read and write something to a file. I could have just said, hello world, how are you? And it will work. But I'm going to take your name. I could use a regular expression here to validate it, since you've done regular expressions also now. So I'm going to take your name, use a proper prompt message. And what will I do is, it will only take a name. But if you want to do it in a loop and say, keep on doing while it is not end, we can do that too, right? So see, I mean, all that you've learned till date, it will work. So you can kind of say name is equal to begin, right? And then use a loop while the names dot lower is not equal to end. See, I've made a loop. All that you've used till now, you can do it here also. There's no big deal. It's just adding more to it. So you've said with begin because you're at least reading one name. You could have said anything but end, right? Then it says while the name of the lower is not equal to end, take the name from the user and now write it to the file. How do you write it to the file? As simple as this. What is the name of your file? Output file. What do you want to do on it? You want to write to it. Right? What do you want to write? The name. Now, if you just say name, by default, it won't put backslash and names will come one after another in the same line, right? So if you want to put a backslash n, what will you have to do? You'll have to put the backslash n yourself. And so I'll show you this way and then we'll change it here, right? You can put a tab if you like or whatever. And this loop will go on till you press an end. Once I'm done, what will I do? Close my file. What was it called? Output file. Now to check that, oh, it really happened, what will I do again? I'll open it again. In which mode? In the read mode. Same file now, you can give it any name you like, though, I mean, usually we give names that make sense. Output file is not making a lot of sense, but I'll say student names or something. I mean, it really depends on what you want to call it. I mean, you can give it any name and open it in what mode? In the read mode, right? Once you have it, what do you want to do? You want to read from it. Oh, keep in mind, we're not in while. Okay, read it. Read the names. Call it names. Read the file. What is the file called? Student file. How do you do a read? Read. And what do you do with them then? Not sure. Why is it going to where it is going? There. And then, or again, remember to close the file. The file is called student file. It's going to tabs where it's not supposed to go, but can't do much about it. There. There. What did I do? I created a file called studentnames.txt. I opened it in the write mode. I asked for names from the user. Whatever their name was, however they entered it, I put it in the file. I asked it again, and so I keep asking it and I'm writing it. I'm asking it and I'm writing it. If the user gives end, I just stop it. I close my file, open it again, read it, and print the names on the screen. And the best part is this file will be saved. I can look at this file after my program is done and finished and idle is closed, right? Let's try it. Okay, so let's try this. Oh, what did I miss? Inverted commas. Thank you. Okay, so somewhere it's going to ask me name. Please input your name and to stop input. So I'm just going to give some names, okay? Since Rupinder said inverted commas. I don't know many names in my class, but here. Right, let's do an end. Doesn't matter how we do the end. Okay, because I've converted into lower, okay? Notice how the names have come? Because I said right, it did right. And then it showed me together. Not very neat. I would have liked to place them on different lines at least. Or put a tab in between. Or put something. But there they are. Anju, Rupinder, Rick, Arya, Stephen, and Ed. Oh, it saved end also. Why has it saved end? Something in our program. Because I wrote it. So it saved it. So what do I have to do before I save it? If the name is not an end, right? So if the name that is given by the user, and we have to take it slower. No, a user can enter anything. Okay, so user can enter anything. Is not equal to end. Then save the name. Therefore, end got saved too. It's everything. Anything you write is what it does. Now it was working, but I didn't. It's just that it went one after another. I want to put a new line after each one of them. What should I do? Put it yourself. Just say output file dot write, and then in write is like a print statement, except that you're not printing on the screen. You're printing it in the file, right? So we'll put a comma, we'll put the single quotes, we'll put the backslash n, we'll put the single quotes, and there. Now it will say name, whatever in different lines. Let's try it. Okay, so let's go again. Oh, something went wrong, too quick. Okay, so enter the name. I think it didn't like the some IO error occurred. So it didn't like the backslash n. It didn't like the backslash n. So what else can I do instead of this? Let's try this. I didn't like it. Something went wrong means there was some. So that's the only thing I've added. So the comma is not working. So I'm going to try it with a plus because it's a string. Let's try that. If it doesn't like it, then I'll have to look it up because logically that's all I'm trying to do. Okay, so let's go AA. Okay, so we are okay now. So it's comma won't do, you have to use a plus, okay? So BB and CC and DD and EE and end. And there it is, AAB, CC, DD and E. I can save whatever I like in a file. I can save numbers, I can save whatever, really doesn't matter. So instead of names, now if I wanted to save marks, I would say, please input your mark and then save it in the file. Right? But in reading, we have to be careful that reading will always assume that what you are taking out is a string. It will always assume that. I mean, it's the default nature. So when you take it out, then you'll have to convert it into an integer. So that's writing to a file. Now, for example, to the same file, I want to append, right? So what will I do now? So this file is already created. Let's append some more names. Let's add some more names, just for the heck of it, right? I'm going to take this again. I'll open the same file, but in what mode? Append mode. And instead of just kind of writing the loop again, I'll just do this write, okay? I'll just say write. Oh, sorry, not write. I'll just say, where are you? Where do I do my writes? I'll just copy and paste. And just for the heck of it. I'm just going to do some, can't remember. Okay, so Ken with a Shan. There, I've added his name. Oops, with the wrong spelling. And so I've put a backslash n myself, okay? I have to, if I, otherwise the name will get attached to whatever. So you can write them normally, which is not a good way because then a loop is an easy one, but let's add Artan's name also. Let's see what happens, right? And let's close the file again. Now I won't close it and I'll see if I can show you that these two names don't get added because they don't move from the buffer. Usually that's what happens, but let's see. Let's do this. Let's go F5 again. Okay, so it's asking for names. Okay, let's do something not too bad. You can always change it into proper case and save it. See, it has printed out 3 names. It didn't, oh, because I haven't read from it. That's not the problem, because I didn't show its contents, right? So now again, so I added some names, but after I added some names, what will I have to do? I'll have to open it again in the read mode like I did here. Here I was printing it side by side, so you were able to kind of see it. So I'll again have to take this read and put it here. Let's see. I'm kind of curious to see before that maybe it will give me an error that you didn't close it and you're opening it again. I'm trying to see if I can get that error. See, I didn't close it after this. I wrote some names and I didn't close it. And then I read it again. Writing programs in a file is not difficult at all. You read, you save, and then the rest of the work still remains the same. So if I say save the name, and save the student number and the marks of a student, the same program that you did in assignment 3, now you will just, what will you add? You will add a file and you will just keep adding every record to the file. So each element now will go inside your, so instead of creating a dictionary, your elements will go inside a file and then you can work with it normally. So anything that you have learned till date, you can save your data in a file, pick it up and work with it. I'm going to see if I'm going to get an error here, some kind of saying the file was not closed or whatever. Okay, so we are okay till here, just because I'm checking for errors. See, Shen and Atom never got added because I didn't close the file. The buffer contents didn't go back into the file. So closing the file is a necessity. Not just because you're wasting resources, this also doesn't happen, right? So there's something in the buffer and now you have to empty the buffer onto the hard disk. So what will I do? I'll close the file. So the file was called output file. Remember to close the file. It happens like I thought it would because it happens in other programs. So here, let's close it. Let's save it. Let's run it again. Okay, so let's go AA, BB, and CC and end. They're there. Shen and Atom got added. So the first AA, BB, CC is coming from when I opened it and showed it. And then the second one is coming from, again, adding the names, closing it and opening. So that's files. See how easy they are, like in the sense of just like a normal file. So instead of writing it on paper, you're writing it on files. And they're powerful. Why are they powerful? If you go back to the directory in which I was saving all these things, I close my program. Let's close it. I can always open it again. Now, if it was a normal program, done. All variables lost, everything is lost. But notice these 2 files. This is the one I created before I started. It's still there. I could have appended data to it. I can open it and add data to it. And this is the file you created. Now the data is never lost. Unless, of course, you delete it. Physically, you delete it, like you delete any file. But the data is there. So now in my grade book, I have all my student mark names and I have their marks in various assignments. Every time I don't run a program to input their marks. It's a file. I download that file. It's a file and then I put it in Excel and I do my math. If I wanted, I would write a Python program to read each student number, read all his or her marks, find the average, give you your final mark. That work has already been done by somebody in Excel, so I use Excel. Whoever has written Excel has done that, right? You can put it in, and you know what Excel is. You can put it in a worksheet, and then you can use the functions or formulas like sum or average. So somebody has written that code to do something. So that's text files. So the file has to be given a logical name. That's on the left-hand side. It's called a file object. The file you want to work with is its physically. You put it in the open. The name could be a relative path. The name could be an absolute address. I'm not going into details about that. I cannot. It will take me quite a bit of time to explain. But Python is all ways of finding out what your current directory is, changing directories, making directories. All commands are available. You can create a new directory if you like. So it does create student information. The file that I created, student, whatever, it's gone in the same current directory. I could given a path there, and it would have created those directories and then put a file. So it's rich. And then I can read from a file. I can read the contents of file together. I can read one line at a time. I can write the contents. Nothing stops. I'm only dealing with strings right now because it's the easiest to work with. You can put numbers, you can put lists, you can put dictionaries, you can put anything, any contents. And the advantage is the file is permanent in nature. That's how it is different from lists and dictionaries. Lists and dictionaries are also data structures. You could collect numbers in a list, you could collect data in a dictionary, but now I have data right in a file. And I can create a file of dictionaries and lists and whatever. I'll show you. Right? We'll take a break here. Right? We'll take a break here and then come back and I'll show you binary files. A little to work with binary files. They're very useful in the sense that you can save all kind of data and you don't have to worry about new line or whatever. Okay? So this program I put on Blackboard for you guys. And so the files are here. They're right here. And then we'll do binary files.
In order to call this file, where should we save this actually?
In the same folder where this program is being saved.
I did it. And it's a document file actually,
Okay.
not a text file.
Now the document file, I already said at the beginning of the class that Word has its own problem. Where did you create it?
Into the programs.
No. Did you create that file yourself in
Yeah.
Word document?
Yeah. Oh, here it is.
Right? What did I say when I began? I said do not use Word to create text files.
I
Yeah.
couldn't find it. I should follow you, right?
Right, so text, because Word has its own format issues. So when you try to read, when you work with text files, you're working with plain text. So use TextPad or Notepad++ or whatever to create them. Don't use it comes up with all kinds of problems.
So how can we call a file in a document file? Call document file in the Python.
Just like you called it, you create it using your Notepad or TextPad. How do you call it? You call it the way that you've done it. Like there's no difference in calling it. So what is happening? What is your program not doing? You're saying?
I can read it. I can read the file. In this folder is where I saved this one.
Okay.
Text and binary over here.
Okay.
So I could not find what you're looking for. So
Yeah, so there's a text, I think it's a word file that is coded. Let's look at your code. Can you maximize this so that I can see it?
So this file is not created yet, so it's showing that I could not.
Yeah, so it's not here, right? So that's coming from some IO error. And then it should move forward. Okay.
Defender has an issue, Cortana has an issue, Snowden like.
It gave you two errors. It said could not find what you're looking for is coming from here and some IO error is coming from here. So some IO error is there. I don't know because maybe it's a document file, it is not able to read it or open it, but something is occurring.
Why is not proceeding?
After this, what have we done?
This one.
This one?
Which already have.
Using
It is again a document file, so I don't know if it's causing a
I tried
problem.
using the absolute path actually.
Okay, so what happens in absolute problem?
It's not reading after this.
Did you write after this? Do you have a print statement? Yeah, there it is, right?
But you see also my, screen is not fixed.
Okay, let's run it again.
We'll do another restart.
Alright, so let's
Try it on like a notepad.
oh, definitely Notepad, but I'm trying to see why this is not working, because some kind of error must come, right?
Yeah.
Because we have, so just comment out the first whatever lines, comment out the whole thing.
I booked an appointment.
You said review.
I figured.
Then the invitation from whoever?
Yeah.
Okay. It was last Tuesday, right?
I guess it was July 20.
Whatever, it was last Tuesday. You can just put a triple star now, yeah, or comment out. Because some kind of error must occur here also, right? Because everything is commented out.
But it just for that side, right?
So we're trying to open, now where is your D? What is your D?
That's a folder where I save this program.
So you have your D folder? Can I go to the D folder and see?
I know, but And then if I have to question for my fourth semester, I'll be able to take the co-op.
It's an external storage?
No. Should I write like CS?
Okay, now click on that folder.
I don't have many options.
Oh, this one?
Yeah,
Either-
That's your folder.
Okay.
not what you were writing.
So
So
Acer
is this in this one?
Okay, so go ahead. Where in this one?
Yeah.
Go ahead in this one?
Yeah.
Okay, so click on that folder again. Okay, copy that
is
and come back. Should have given you some error. Okay, now replace that name, except till the file name. Yeah, replace it. There is where it is. Okay, now what are we saying? You're saying personal information, read from the file. And then you're saying print to the file. Oh, there's a try. Okay, let's see what's in the try. Where are your accepts?
Oh, here.
Okay, so we should have something, right? Okay, let's try. Even if it found an error. Something in the. So I think it's to do with the document files.
Yeah, I'll try. Thank you.
fire. I gotta figure out, like, the problem is, you do not have a local policy editor on, home edition. It doesn't have policy editor. And I want a new policy editor, it's completely shut down. The firewall. It completely shut down for time. Nothing, everything. There's no reason to.
We were done it?
Yeah.
She's useful. Just like,
She's useless. Completely utter useless. I don't use her. Do you use her now? You use the search.
yeah.
And you don't need the search. You don't click on the search. Let me show you a trick. I found online. They tell you you need what you don't. So you see you got here? As soon as you set that, it'll open up search.
It's saying like we're done.
Yeah.
I don't need, I know, so I don't need to.
You don't need it at all. You can completely turn it off and search will still exist. The search is a core function. It existed long before from that. When you open up your start, it would be a little, like, magnifying glass. They just hid it and attached it to Cortana settings. What is this? Uninstall. What's that? What functions I don't know. Unfit from start, don't care which one of the store. Calendar here, whether here. Nope. Now we'll update. Every time I log on.
Okay, guys, let's start then. It's been 20 minutes. Whoever wants to come back, they can, and whoever is not interested can do much about it. Always, some people object on doing quizzes, some people object on doing assignments, so you can make everybody happy, right? So whatever it is, it is. It's really becoming a challenge to teach non-programmers programming if they're not interested. Okay, so let's look at another way now. So we were, let me open I had closed that. There it is, right. So the first one I had worked was with what did we just work with? Where did I keep it? Oh, in files. We'll just call it text files and binary files that way. Okay. Okay, so let's look at what binary files are. So as I said, text files can be read and edited by humans, right? Like I showed it to you. You can look at them, you can read them, you can change them. Binary files are something that if I try to open, if you've seen it before, if you try to open a file and you can make head or tail out of it, it's basically a binary file. It is just not being opened by the right program maybe, or it is just a file that is nothing but zeros and ones. Okay, so now let's look at how I can save data in a binary file and how I can read data from a binary file without even looking at the content. So I know what I'm saving. What I'm reading is definitely what I have saved, and then I'm going to work with it. Okay, so let's look at it. Now, to work with binary files, the first thing you have to do is you have to import a module called shelf. Right, so this, if I have not misspelled it, yeah. So this is the module that you need to import when you work with binary files. Because, as I said, and just for your information, these modules that are being imported are just .py files, nothing much. They themselves have been written using Python. They're py files. I'll show you how to write your own module and use it. Okay, I'll show you that too. Again, using files. Okay, so to work with binary files, import this module called shelf. And now I'm going to work and show how to open a file and how to read and write from a file. The best thing about binary files is you just open them and you can read and write and append anything to them. You don't have to kind of say open it in the read mode or open it in the write mode and so on and so forth. Okay, so let's work with something. Let's create a binary file. You will notice that it's a little different from what we've done, but at the end of the day, doesn't matter to us since we are writing a program, doesn't matter to us whether we are working with a binary file or a text file. Okay, so let's create a shelf file. I mean, you could have called it anything you like. I've just taken the name from the online book, and using the open method of your module, open a file called whatever you would like to call it. Now, binary files usually don't have an extension because they're not text files, they're not document files, they're not py files. They don't have an extension usually. I mean, what would you give them as extension? They're basically nothing but combinations of zeros and ones. So binary files, you could call them .bin if you like. It really doesn't matter. But usually they don't have an extension. Because I think you should be aware that 20 minutes means 20 minutes, right? And I have complaints from other students saying that you guys disturb others when you don't come on time. So we went on break at 9:41, which means the class had to start at 10:01, which is 20 minutes. You take your time leisurely, come in whenever, leave whenever. I don't think that will do. If you want to attend my class, please see that you're here on time because I'm here on time, right? And if not, that's perfectly fine by me. At the end of the day, it's the students who will suffer. I'll still keep doing my job, which I am doing. And I have written complaints now coming from students saying that people are disturbing in class. They come at any time they want, they talk to each other, and it's disturbing the class. So I would request you to maintain some kind of discipline in class. You're only 10 or 15, and if you can't maintain it, you should not come to class. And see, again, there are 3 or 4 students. Once I start doing things, they move it whenever they want. And that's ridiculous. Like, it's not how it is. If you're interested in attending the class, it has started 7 minutes back. And if not, please take your laptop. Don't come to the class. It depends on what you want to do, right? There is a time. If you're interested, move it. If you're not interested, no late comments. Interested? Yes, I am. So I have marked a few assignments of assignment 3. And if you're interested, and again, it's not being done too well. People who know programming are doing it well, and people who do not know programming are still that way. So if you would like to email me or ask me your mark, because it will take me some time till the end of the semester to end of the week to finish it off. If you're interested, you can come in my office hour and ask your mark, and I'll show you your mark. Okay, I can't open it because till I finish everything, I can't do it. Okay, so the quizzes were being done or are done so that you have some extra or different way of acquiring marks. Not everybody likes programming, but not everybody likes quizzes too. So there are always complaints either way. So, and they'll always be, right? With quizzes, the thing is you have to kind of memorize stuff. You can put it on cheat sheets, but you still have to memorize it. But I am trying my best to give you marks so that you can pass the course, because that's what you're here for. So you are trying your best, so I'm trying my best. But at the end of the day, programming cannot be learned with multiple choice questions. It's all doing. That's what programming is. You have a computer in front of you. You can test things. If they don't work, you know you can fix them. With a multiple choice question, for example, you have something, you don't know whether it's right or wrong. But anyway, okay, so we are working with binary files now. To work with binary files, I need a module called shelf, which I've imported. And the advantage of binary files is you just open them. No mode is required. Once a binary file is open, you can read in it, you can write, you can append, you can do whatever you want to do with it. Okay, so I've created a file I've called it shelf file just for the heck of it, because that's what it was called also from where I picked up the example. And I've opened a file called my.data. I haven't given it an extension. Usually binary files do not have an extension, right? Like text files are called .txt, document files are called docx, Excel files have an extension of XLXS. They're kind of common, but binary files don't have an extension. But if you like, because you are working with it, if you like, you can call it .bin if you like. Right? It depends on you, but usually you will not see them. Why? Because you cannot open them and work with them using any program. You have to always work with binary files using some programming language. You just can't open them and look at them and do things with them. You cannot, because they're all coded. So because it cannot be opened using any program, usually they don't have an extension. Okay, but there's no rule which says you cannot. So what I'm going to put in this shelf file, you will notice, I'm just going to put a I'm going to create a dictionary and save a dictionary in this binary file. And then I'll show you how you can read from it. But for now, just to write data into it. Okay. So they don't have to be opened in either read or write mode. They can do both once opened. So the no mode is required. And once you open them, both read and write can be done. Okay, so we don't say comma R or comma W or whatever. Okay, what I'm going to do is I'm going to just create a kind of a list here and then try to put that list in a file and so on. We have done normal strings in the other file. This one is a little more not complicated, just a step further. Okay, so I'm going to create a student list, student names, right? And you're aware of how lists are created. They're created in square brackets, and each data is separated by a comma. And again, I'm using strings just to keep it simple. And there is my list of students, right? It could have been list of marks also. I'll put that too also for you. It's no big deal. It's just that showing you it can be done. I'll just go between 0 and 10, okay? And again, there is no relationship between the two yet. I'm just kind of showing you that you can say whatever you like in a list. Really doesn't matter. Okay, so I've created two lists here. Of course, when you save something in a file, you have to have data. You could be reading that data from the user, like I did using a loop in my last program, or you could be using hard-coded data. Really doesn't matter. Now I want to save this data, my student names, in my file. So I'm going to say shelf file, right? And I'm going to create a dictionary. The shelf file, the binary file I'm going to create is going to have a dictionary structure. That means it will have a key and it will have values. It will have a key and it will have values. Okay. So let's try to just like with a key. And you can call that key whatever you like, but this is what I'm going to do. I'm going to create a key called names. It has nothing to do with the student names word. It's just names, right? The key is called names. And to it, I'm going to assign the student names. I can make it more pretty also. I'll show you how to work with pprint also today. But anyway, right? So what have I done? I've created. Now, I don't know how it will be saved. I'll show you. I mean, I'll show you the file and you can make head or tail out of it. But what I've done is I've created a key called names, and with names, I've associated the student names, right? I'm going to close the file. Again, just very simple to begin with. Right, my file is closed. Now the file is created. You'll say, where did you create it? Here, this is my right part. Right, I've just put it in my shelf file with a key called names, and the names has a list. So it's a key. The key is called names, and the list is called whatever. Right, now you'll say, who will prove it? I will prove it. I'll read it from the file and I'll prove it to you. But let's kind of just run this file. Oh, so I haven't saved it. So I'm going to save it where I've been saving my other files. And I'm just going to call it binary files. The previous one, just to kind of differentiate it. Previous one was called text files. I mean, I don't know how you want to save it. It will have an extension of .py. Okay, let's run it. Uh-oh, shelf file is not defined. Somewhere I've made a mistake of my spelling. Yeah, I have here in my close. So that's a name error, right? That's a name error because you've used a name that does not exist. So by this time you should know when you see errors that what do these errors mean. Okay, let's try it again. Let's run it. Nothing will happen, but the file will be created. I don't have a print or anything. Okay, so something got created. Let's go to that folder where that file is and notice how for the my data that I've created, 3 files have been created. A backup file, a .dat file, and a directory. And none of these files are human readable. I'm going to open them for you. Then, I mean, it got an extension on its own. I didn't do anything. What's in the DR file? I don't know. It looks like as if it is a normal data file, like it's a notepad or textpad file. It says I cannot open this file. I don't even have a clue of how to open it. So here it is. It says if you want to open a file with a dir extension, you will have to download the adobe.director and then open it. Because it's a binary file. It's just a special kind of file. Okay, let's try to open the other one if I can open the other files. The back doesn't look too bad. Let's see if I can open that. No, it can't even open that. The dat, okay, let's see dat then. No, it can't open any of the files because all these are binary files. If I try to force to open it using maybe textpad or notepad, see here. So you can make head or tail out of it. I can see Anju or whatever, but do you notice how they have special characters? Because it's a binary file. So it's not human readable. I mean, you can't read it and say, you don't even know what these first characters are. Or you don't even know what these characters are. Or Artem has something here. So all returns or whatever. So if I try to open this file using textpad, I don't know what it will be. But there it is, names 0,57. I think it has saved that names is my key. And I don't know what 0,57 means. Maybe the size of that names, all those names together. So I have no clue. I mean, I could always, which don't make any sense to humanize, right? Now then comes the question that if I cannot work with, I mean, I've created one. I know what I've put in it. I've created a dictionary. If you kind of think of it, I've put a dictionary. I've created a dictionary with names as the key and students' name as its list. So if you know, or if you can guess from what you've learned till 11 weeks from now, you've created save the names with the key. So you have a key and you have a value pair. And what is your values? And the values are a list. Notice why? Because I had a list here. That was a list. So having known and done Python for 11 weeks now and know that what is a dictionary and what is a list, let's retrieve the values now from this shell file, right? Let's read from this shell file now. I could have made it a little prettier, and I'll show you. You can use the pprint module to make it pretty, but that's what I want to do. Okay, so let's open it again. And nothing changes. I just open it. I can read from it. I can write from it. I don't have to say, oh, I'm reading or writing. Okay. But what is the sense of opening and closing it again so that my pointer goes to the beginning of the file? So you open it again. Now, just to show you, I don't want to this is just to show you. It's called the type of the file. It's nothing to do with the data inside it. I had to find out what was the type of the file. So I went and looked it up, and it said you can find the type of a file by saying type. That's a function that is available, and the shelf file. It's kind of an odd, I can't remember what it said, but whatever it was. I'm just going to print it for you. What is the type of this shelf file that got created? Now, I know it is a dictionary. You have to know how you're saving. What are you saving in a file? Are you saving numbers? Are you saving names? Are you just saving one name per line? You could save anything. What I have saved is a dictionary, right? So since this file has a dictionary object inside it, I mean, I've only put one. I've only put one, right? It's only one. What I can do is I can print, if I like, if I can print the file's keys. Remember the method, keys method? You also have items and everything. If I want, I can print the keys. So take it and say dot, call the keys method. I only have one, but at least I have one to show you, right? So print the keys. I mean, I only have one, but anyway, we can add more, right? And if you want, if you remember, we also have a method called values. We also have a method called items. You can print all of them. So if you want it together, like value, item, we can do that way also, but I'll just do it one at a time and then we'll do the items. I mean, of course I would have used a loop, but I know that's all it is. There's nothing else. This is just to show you, and then I'll make it more clearer. Let's see. Because I know and it's very important. You exactly have to know the contents of the file to read it from the file. If this was a file of numbers, I wouldn't be reading it this way. Since I know that it has a file and it has one record, and what does that record have? Names as the key and whatever as the list as the names. It's because I know it. If I add more, I can keep. So therefore, I was saying you could have created a file out of that student name and the marks and put it in a file, in a binary file or a text file, really doesn't matter. And then read from it and work from it. See what happens. Let's see what happens. Oh, I should have put it in a try catch, which I forget. Here is the type of your file. Kind of odd, right? You don't even know what it means, but that's the type of your file. Here is your keys view. Oh, something is not right. It's giving me a view. How can I make it pretty? How can I make it pretty? What was it saying? What was it view? It's a keys view and a values view, and it is an object. Okay, so let me try this, because you can convert it into a list. I'd done this when we were doing somewhere I had mentioned it. So I'm going to convert it into keys and list and see. List is a function that creates a list, okay, of anything. So I've said, okay, create a list of the keys and create a list of the values, though there is only one key for me. And let's try it again. Oh, better. There it is. See, so I knew there was an object. I knew there was a keys view, but so here, this, I can't do anything about it. This is just the type. Like integer is a type, float is a type, so on, they are types. This is a type of a binary file for your information. But when I convert it, when I use the list function on the view, I create a list of keys. So that's my keys, the names. Remember, names is the key. And then the other one is my list again, but it has only one value because I only had one of them. Now, which means what? You can keep adding whatever you like into a binary key. All you have to know is how to read it back. So you could add a student number, his or her marks. Another student number, his or her marks. Another student number, his or her marks. Try that now. Try that with me. Do you understand the concept? Right? So now I'm going to do this with you. Once you know the concept, this was the easy way of showing you the concept, but not a very useful file. All I did was I opened it. I just put a list of some names and I put a list of marks. But what I'm going to do now is, if I take somebody's program or try to write my own program here, which is going to ask for the student number and then the marks of the student, I can put it in the file, read it back, and do math with it. It's so powerful. And you can even do this. If you know the name of the key, I can even do this. I can say print, what was it called? Shelf file. And what was the name of the key that you're interested in? Names. Was it names? I think it was names here. What do you think it will print? It's just like printing The names, the value of the names key. Oh, will I have to convert it into a list again? I think so. I'm not so sure, but I think so. I'll have to create it. Let's try. Otherwise, I'll put it in a list. No, I didn't have to. Here is what is associated with names. So what, I mean, again, I'm not saying that a binary file has to have a dictionary structure. A binary file can have anything you want. You can be putting just numbers in it, nothing else. Like just adding a number to it and nothing else. So it can be any type of file that you create. I showed you something that was more kind of, more, I would say tough, but anyway. So here, instead of putting student names, I could just add numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the structure of this, the structure of the binary file, if you look at it, is like a dictionary. It has a key and it has a value. It has a key and it has a value. Now that key could be anything. It could be a string, it could be a student number, whatever you like. And the values can be maybe marks in one assignment, maybe marks in your string manipulation quiz, or marks in a number of assignments, which again can be a list. Right? So if I wanted to create a list of, again, it's not human readable, but via a program, I can do whatever I like with it. So that's a binary file. And I could have done the same thing in a text file also and be able to read it with human eyes. But that was a different example. And here I'm just giving you a different example. And there is no end to it. You can make files as complicated as you want or as simple as you want. So here I just made it a little complicated. So I don't even need these marks. But if you wanted to, you could just, if there were 4 students, 1, 2, 3, and 4, you could have 4 marks and then you could have added the marks. You could have seen the names and you could have seen the marks, seen the names and seen the marks. Like it could be anything. It's really a file which is binary in nature and cannot be read by human eye, but it is your job to do whatever you want to do with it. Right? So to read it, I said, give me the keys. So there's the function keys and there is the function values. How do you get it? If you want to use an items, if it had more than one data, I would have used a for loop, gone through the items and showed you the items. So now you will add your list learning to this to make it more useful. Just because I'm doing this, I didn't get my battery today, hopefully 59 minutes, I should be okay. Just because I want to show you something. If you want to make your printouts a little pretty, and I've done this before, but I'm going to show you that you can do an import of ePrint. Do you remember? I don't know if you remember. I had shown this in one of the classes when we were doing dictionary. How to make your dictionary more pretty. Instead, otherwise the dictionary just comes as one long list. If you want them one per line, we had used this pprint module and we had used the pprint method in the pprint module. I'll show you something with this to make it pretty. It's called pretty printing. Just because it's prettier. And the pretty printing is done with this module called pprint. And the whole thing is all these imports that you are doing, all these imports that you're doing are nothing but .py files. Let me show you. Let me create a py file for you that has some data in it, and then you can import it in another program and just use the dictionary again. Okay, let me do this for you. I kind of created this for you, especially for this. Let's create a student's dictionary, a student's list. Like I was saying, okay. In the students list, I'm going to create dictionary objects. Okay. So inside each dictionary object, I'm going to put some whatever. So I'll say name of the student. And remember, it's key value pairs. So key and value is Anju. I'll put a comma. We'll say marks, maybe your total mark in the course. And no double, single. And let's say I got 88%. So what am I keeping in my dictionary? The name of the student and the average mark. That's about one student. Okay. Now let's go to another student. Same thing. I'll kind of copy and paste and then I'll change it. I'll change it. I mean, you could do more than one. I've just gone with, and I'll put it on different lines so that it is readable. Okay. Let's just change it just for the heck of it. So it's my final mark or whatever. Let's go with Rupinder. Let's see, Rupinder has, are you expecting Rupinder? 75? 85. Let's give you 85. Good enough mark. And again, these could be numbers or these could be strings. We know that, right? Keys are usually strings, but the data could be anything you like. Let's go with Shen. Shen knows programming. Let's give him 98. He's trying his best. Let's go with Artem. Artem has done his assignment well. I've marked your assignment. Let's also give him 88. So you are at par with me. Let's go a little lower for Shen. Here. There. Okay. So I've created a list of dictionaries. Maybe you haven't seen one. You saw the other. You saw a dictionary of list. So you had a dictionary in assignment 3. And in the dictionary, you had student and the list. Student and the list. This is a list of dictionaries. So again, confusing, yes, but a big deal, no. Right? You can combine anything with everything. That's what programming is all about. Now, what I'm going to do is, I'm going to save. Right? I'm going to save this data, the above data, or the above list, I should say, in a pretty format by converting it into strings. Okay, so there is a function. So I'm going to use the pprint is the module, .pformat is the name of the method that saves it as a string. You've done pprint before. I'm saying pprint pformat. And what do you want to save is this. I just have to kind of, because I haven't used it a lot. This is not available in all languages. I have to kind of refer to my notes. Okay, so I've saved my students' data in a p format using the pformat method, which for your information saves it in a string. And the pprint is the module that I am using. So I have a list. Each list has a key called name, a key called mark. The value for name is a string Anju and the mark is an integer, right? And we know that dictionary can have any number of keys, any number of values. Keys must be unique and the types can be anything. Okay, so now if you want to print it, I'll show you how it prints, what will it do when we print it out, which is the biggest thing. Okay, now I'm going to create a file object and started calling them objects because they are objects. Okay, I'm going to, give me a minute. I want to save it. I've saved it. I should be okay. I'm going to try, right? Now I'm going to open this. And give it a name. Give me a minute. As I said, this is entirely new to me, so it's not a big deal, but okay, I'm going to create a my students file and I'll open it in the write mode. So it's called not pretty printing, it's called pretty saving. I'm not creating anything. I should have put this actually in my text file. I'll move it to the text file. But this was more pretty printing, not pretty saving. It's called P for pretty, just so that you know. Okay, now I'm going to save this students in this file. I'll move this, guys. It's because I was doing this is not binary file. Can you give me a minute so that I'm going to open the other file. This one is complete. This was a binary file, and so it was okay. I'm going to open that file I was, just because I don't want to. It was called files. I don't find it. Oh, there it is. This is where I was doing. No, that's not it. File open. There it is, text files. Okay, I'll put it at the end of this. I'll still be in try catch, but I'll put it at the end of this. I'll put it here because it's still saving in a text file in a pretty form. Binary files is what I've told you is all I wanted to tell you, though again, as I said, I can do much, much more. I'm trying to restrict myself only to an intro to files for you, okay? And that is what I'll expect of you. Okay, so I'm again going to save in a text file, but it is called pretty saving here. So I've just changed the file, and the other one was running. This was already running, right? This was already running, so this is okay. But this was to show you how you work with a binary file where you just open it. You can put whatever you like in it. And I also showed you it is not human readable. You cannot read it with human eyes. Okay, let's come back here. This was interesting. I found it and I wanted to show it to you. Okay, so I've created a students object. It's a list of dictionaries. Please understand, it is a list of dictionaries. So students is a list of dictionaries. If you can't figure it out, please write it. It's a list of dictionaries. List why? Because you see that square brackets outside. And why a dictionary inside it? Because you see curly brackets inside, right? That's how you recognize it. Okay, now I've still in the same accept and block and whatever. Now I'm going to save this data that I just created, this one, in my file called students. So with my file.object, I've opened it and I'm going to do a write. Right? Remember, as you did before, I'm going to do a write. Okay, now what do I want to write? What I'm trying to show you is this. And I'm showing you that how you can use this file, mystudents.py, and import it in another file and use it. It's a data file and you can just use it as if, oh, all the modules that you are importing for your information are nothing but py files. They're just normal files that have been written by somebody, and you can open them and read them. They're just py files and nothing files. So if you use a length function, you can read the code for length. If you're using the rsplit method, you can read the code for rsplit. Somebody has written that, called it .py, and you import it into your code. Okay, that's all you do. Okay, so I'm going to write into this file, and notice what I'm going to do. Just so that I can show you that these are students' data. Students is equal to, it will be a normal text file, okay? And do a plus, and then do a p print. You know what? I'll do it right here. Why even do it here? I'm going to take it from here and put it right here. Why do it two times? And I'm going to add \n to it because we already know it doesn't do it. So I've created a py file in which I'm going to save this data. You will say, how will it come handy? You have a list of dictionaries, you can import it and you can read from it. It's as simple as that. Let me first create it for you. And then let's close it. So 3 steps and close it. So I'm not writing those steps again because we already know what they do. Save the student list as a pretty string object. So I've said students is equal to, and then I've saved whatever you, like I did a pp.format and I saved it. Now let's see if I can open this py file, and it is a normal, I didn't give it an extension .ext, but it is a py file. Let's see what is in it. Okay. Now, if need be, I can import this file. I can show you how do I import it here. I can import this file as if I was importing a normal file. I can say import my students. Here, I can say import my students. And then if you wanted to just print it, say my students. And in what name did you save it? You said dot students. There, it will print it out for you. You want to put it in another program, sure, but it's just a normal .py file. So let's go one by one. I'm going to first put this in comments. The whole concept that I'm trying to bring to you is the imports that you have been doing till now are nothing but .py files. Let's do this first. I create a file called mystudents.py, open it in the write mode, and I put some student data in it. Each student data has a name and a mark, a name and a final mark, a name and a final mark, and so on. There's nothing else in it. But when I saved it with a kind of a key. I saved it with a kind of a key called student so that I could retrieve it afterwards. Let me just run this for you first. Source must be saved. Okay to save. Oh, invalid syntax. What did I do? Oh, you know what? I was in a try catch block, guys. I forgot. I was in a try catch block. So here, and this when it happens here, and this one happens here. Okay, so that was the invalid syntax. I was in a try catch, so my indentation was wrong. Oh God, okay, so this one is the other one. Oh, some IO error occurred. So the error has to be from what I've written. Okay, what is the IO error now? It has to be from something I've written because this is the only new thing that I've written. See if I've missed a comma or a dictionary or something somewhere. I must have. It's always the user who has to be blamed. Nothing else, nobody else can be blamed. So please see if commas are available. Yes. If dictionary has been closed. Yes. So that means file error, file IO error. Okay, so somewhere here, open it in the write mode. Write it. So writing is maybe creating a problem. Close is fine and open is fine. So somewhere here. What have I said? The print.p format? No, I've already imported it. There it is. Where is my p? Where are my import statements? Oh, I was doing it in the other file and I forgot to do it here. Thank you. Yep, that's missing for sure. Okay, that was in the other file that I was doing it. Let's try it. Okay, now what is it asking? Oh, the names. I'll just do an end. Okay, so file got created. The .py file, thanks. There was no import statement, right? Because I was doing it in the binary files. I copied the code, but I forgot the import. Okay, so the import was missing. So the file is ready. You'll say, show me the file. Let's see the file. I want to show you the file. It's just a text file. So the file was called mystudents.py. It has a .py, so it will open up in edit in your idle, but I can always open it in TextPad. There's nothing wrong. I can always open with, remember I said you give me here. So this is what has been saved. Students is equal to mark is 88, name is Anju. Mark is 85, name is Rupinder. Mark is 90, name is Jen. Now it has kind of reversed it. I said name this and mark this. It hasn't lost information, but it has saved it in a reverse order. Maybe the P format does it. I don't know. Like I didn't do anything. I just said saved it, use the P format method. But notice this is what has gone into the file. So you have defined a variable called students in which, what is it? It's a list. So what have you saved? You've saved some variables. Now if you want to use them, you can just pick them up and use them. So you don't have to enter the data over and over again. Now let me show you its use. In the same program, now let me, though it should have been in a different program, let me import it. I'll take my import my students right here itself just because it wasn't just to show you that it's here. And then I'm going to print my students.students to show you. Or you can just take this import statement, create a new file and say import my students. What will you have? You will have this file that we just got created. So I'm going to just do it for you and I'll show you what it will print. I've done a print here. I'll show you what it prints. It will exactly print what we see there. If you're interested in showing the first one, for example, now it's just data now. You can say, what was it called? My students. And suppose you are interested in the first element. So the element is 0, and what did you call it? Students. Okay, so students 0. This will give you the first student's data. Students 0 will give you the first student's data because you gave it a name students. Remember, you gave it a name students. So when I say students 0, what will come? This is the data you will get. 0, 1, 2, 3, 4. You can pick up any data that you like. It's just normal. Like you can even change a value if you like for your information. But here, let's print another thing with the same student, right? I mean, I can pick up anything, but just because I'm writing it like here. So from this student, I'm only interested in the name field. So remember how you can say name. Remember, it's a dictionary. You can pick up the key value name and it will show you the name. So the advantage is what? The advantage is that you have saved your data in a file. You can import that file wherever you want and work with it. So all the modules that you have been importing, if you kind of go on Google and look for them, they have nothing but code in it. And which code? Python code. They're all .py files. They're all .py files. So if I'll do this for you and then I'll show you the sys or the OS or whatever file. Let's run this for you. So it should say Anju. First all students, then only Anju, and then Anju as the name. Or sorry, when I say name here, it will show me the marks of Anju. Right? This is the key. What will you get is the marks. Okay. This is what I'm hoping. Invalid syntax. Why? What have I missed? Oh, must be missing a bracket. What else? Anywhere else am I missing a bracket? No. Okay, so this was the one that was we were doing before. I'll just go A, B, B, and end. Here, notice, this is my list. The whole list has come. I'm not sure why is it doing in the opposite order. Maybe it's its nature. Okay, then I only said I'm interested in 0. So here it is, the 0th one. Remember, this is the whole list. And then this is the 0 one. I was at position 0. And then name is giving me my name. My marks will give me my marks. So files are really, if you kind of think of it, files are very powerful. Why? 1, because they're of permanent nature. And 2, if you've noticed, I can put strings in it. I can put lists in it. I can put dictionaries in it. I haven't shown you numbers, but I mean, I can put numbers. You can save whatever you like. The whole objects, you can save objects inside a file. And then, of course, you should know how to read them. You can create text files if you want. You can create binary files if you want. The only thing with binary is you cannot read them with naked eyes. You have to kind of read them with the help of a program. So if I wanted to see my name, my mark, or what will I do? Instead of name here, if you copy this, it's just a variable. A variable called students has been created, which has nothing but it is a dictionary. It is a list of dictionaries. So if I wanted to see my marks, I'm hoping it will work because it's just a, what did I call it? Mark. Remember, name key, and this is the mark key. So name was showing me Anju and mark will show me 88. Should show me 88. There it is. So I could take this code, which I did in because I was a little short of time. I looked at time. I said, if I create a new file, I'll just put it in. You can take the code after the import, put it in another file, and it will work. It will work as if it was just a normal file. So if I take this code that you've just written, now that I know it works, I can do this. From where did we start doing it? We started it from here. You can take this code and just import this my students wherever you want. So take this code and put it in a file, and then take this code and put it in another file, and it will work. You can create 2 files, one where you are creating the object and 2 where you are using the file. So import will say import my students. What am I doing? I'm importing a .py file. Therefore, I gave it an extension .py. I didn't give it any other extension because all import files, all that you import have an extension of .py. Look it up. Anything. Look, pprint that I've used. If you go and look at pprint.py, just Google it. So pprint, you'll get a whole code. Except that maybe we'll have to kind of, I'm sure it's available. I should have said code of pprint.py. Come on. Looking up. Oh, it's looking up www. From where did www come in front of it? See here, it's in documentation. So somewhere they must have given you the pprint module defines one class. There it is. Somewhere they must have. They are doing imports. They should give us. It's free. So if I click on this link, the pprint module. So it's present in the lib/pprint. Oh God, somewhere the code should be somewhere. I can't find the code. It's called a pretty printer. I'll find out for you. Somewhere we should be able to look at the code. Show source. No, this page shows source. But yeah, they're just .py files, nothing else. So therefore, I created a py file. What did I save in it? Some data. And then I use that data like, I don't have to retype it over and over again. So I saved a dictionary, a list of dictionaries. And you can access it using the for loop. You can, I just did name 0. I just accessed the 0th element. Of course, you can write a for loop and access whatever. So from point of files, at the easiest, at least, you should be able to save something to a file and you should be able to read something. If nothing has numbers in it, right? So save some numbers in a file. So take input from the user, save it in a file, bring it back, find its average, and print it. Maybe that simple an example is what I'll give you for a small assignment. That's not a big job, right? All you have to remember is like opening in the read mode, you're reading from the user, putting it in the file, closing the file, opening it, reading it, summing it up, finding the average, and that's it. If the file is not empty, of course you should have something in the file. At least an easy job to be done because there's nothing that I can do for a quiz. You know what I mean? Like there's nothing in a quiz. With regular expression and strings, I had functions, so many. But here, what do you have? Open, close, read lines and like 5 things to ask. And what will I do? Write the syntax? No. Right? So I'll make up a small example, small question for you so that you can do it. Very small, very simple. No functions, nothing. Just input to be validated using try except like you've done. And then putting it in a file, reading it back from the file, summing them up, maybe counting them. When you read, you can say count plus 1 and showing the average. I'll write a very simple question, okay, to make up of what is left. Let me see how much is left. Because till now I haven't decided about your quizzes. Should they be 5% or should they be 10%? People are doing okay. I haven't seen great. I looked at the marks. They're not great that I can say, oh, let me give 10% for it. That's why I didn't say anything at that point of time. If everybody had done great, I would say take 10%. But it's okay. It's not too good. So at the end of the day, I've given you all choices, which means you still have to really work hard, which you will.